So in the last video, we talked about all the logistics and the ideas of the mole, and now in this video, we're going to take a look at some sample problems. So we started this problem in the last video, and then I realized that I forgot my calculator. So oh, my hair's looking lovely. Um, Here is the problem that we set up. So we wanted to know how many atoms given this many moles. So atoms to moles is using Avogadro's number. So sorry about all that noise. We're using Avogadro's number. Nowhere does it mention grams, so I don't have to use molar mass at all. So now it's a matter of taking 3.25 times 10 to the negative 4 moles and multiplying it by 6.02 times 10 to the 23rd atoms per mole. So you wind up with 1.9565, but I only want 3 sig figs, so 1.96 times 10 to the 20 atoms of fluorine. Did I say iron at some point? Might have said iron. I apologize. Some students say, do I have to put those labels there all the time? Do I need moles and atoms everywhere? Do I need F everywhere? And our response to you is yes. You need all of those labels everywhere, just like I've done, because you're starting out small at this point. We are only using one substance, but it won't be too long before you are actually using multiple substances within the same dimensional analysis problem. So you need to have everything labeled. All right, so next question says, what will be the mass if you have 9.85 moles of silver? So now I do need mass. I don't need atoms. So hopefully you're realizing, oh, what I need to use is molar mass now, because that's what gets me back and forth between moles and grams. So the substance is silver. So I pull out the periodic table and I see that 1 mole of silver weighs 107.868 grams. So that's going to be my conversion factor. So I'm going to set up the problem 9.85 moles. Now, if you want to abbreviate the word mole, they let you pull the E off. So lucky you, saves you a lot of time if you write MOL instead of MOLE. So moles is what I need to get rid of, which means moles needs to go in my denominator on my conversion factor. So we said that it's 107.868 grams of silver. So the moles of silver will cancel out, and I'm left with grams of silver. Again, 3 sig figs means that my number is going to be, it's 1062, but for 3 sig figs I got to make it 1060, and that is grams of silver. Okay, so now you've seen 2 problems where we're using the conversion factor where we're canceling the mole out, so the mole's on the bottom. Now let's take a look at some others. You can remember you can flip conversion factors. So here's one where mole is going to be what we are solving for. So mole's going to have to be in the numerator. So how many moles are there in a sample of 8.70 times 10 to the 25 atoms? So 8.7 times 10 to the 25 atoms of lithium, and I'm going to multiply by, again, moles and atoms means Avogadro's number, so 6.02 times 10 to the 23rd atoms of lithium and 1 mole of lithium. Remember that the 1 always goes with the mole. The number always goes with the other unit, whether it's mass, grams, or whether it's atoms. So now I'm dividing those 2 numbers, and I wind up with 144.5, so technically 145 to the right number of sig figs, moles of lithium. So far, so good? All right, 2 more problems to go. Next one. How many moles of barium are in a sample with a mass of 100 grams? So I've got 100 grams of barium. I need to get to moles. So grams to moles means, once again, molar mass. So I look on my periodic table. Barium weighs 137.327. So where's that one going to go now? Grams has to go on the bottom. 137.327 grams of barium, so that the grams cancel out. 1 mole of barium in the numerator, because that's what I'm trying to find. So I'm going to do 100 divided by 137.327 gives me 0.728, and I can do 4 sig figs here, 7282 moles of barium. All right, so far you've seen 4 different ways of using these 2 conversion factors that we have, but we've always used them independently. This last question, if you take a look at it, we're actually going to use both in one problem, because we want to know how many atoms, not how many moles, how many atoms are in 250 grams of copper. So I'm starting off with grams of copper. I don't have a direct conversion factor between atoms and grams. I have to go through moles. That's the big idea to moles. You're going to see as we talk that mole is really the avenue to getting to a lot of different units. So 250 grams of copper, the first thing I have to do is get 2 moles. So I want grams to cancel. I want moles of copper. So I look on the periodic table. 1 mole of copper is 63.546 grams. 63.546. Okay, if I stopped here, my answer's in moles. But I don't want moles, I want atoms. So now I have to use the second conversion factor that we know, Avogadro's number. Moles need to cancel, so moles are going to be on the bottom. Avogadro's number is 6.02 times 10 to the 23rd atoms of copper. So grams will cancel, moles will cancel. I'm left with atoms, so now all I have to do is the math. So I've got 250 divided by 63.546 times 6.02 times 10 to the 23rd is equal to 2.4 sig figs. So I'm going to write it down here. 2.368 times 10 to the 24 atoms of Cu. And if you think about it, 250 grams, 1 mole is 63, so there's more than 4 moles here, or right around 4 moles, okay? So 4 times 6 is 24, so it works out okay. If you can kind of check yourself with the math that way, that would be good. That way you know you're on the right track and haven't done some sort of silly math mistake. Okay, so there is, like I said, one of the most important concepts of the year, the mole. Avogadro's number, and especially molar mass, we are going to use a lot. So make sure you get comfortable with it. You've got some problem sets to do, and as the week goes on, we'll do some other activities as well.